This video explains the basics of UDF and knowledge pattern on a staircase design. A feature is a geometrical object to represent a sphere, for example. It has input, in this case the center of the sphere, and parameters like the diameter. But you can define your own feature, and UDF for user-defined feature is for this purpose. To create stairs following a curve, define a UDF step and instantiate it along the curve multiple times with a knowledge pattern. The knowledge pattern is a script that handles lists. In this example, a list of planes representing steps levels, and a list of UDF steps recursively instantiated between two planes of the list of planes. Therefore, the knowledge pattern inputs are the 3D curve and riser height parameter to compute a list of planes, the same curve and two planes of the list with a stair width parameter to compute every step. Important: the UDF is a template that could be stored in a different part. To be reused inside the script, it must be stored in a resource table. For the data structure, the main body contains the stairs. A geometrical set called input contains the 3D curve input of the stairs. Another body contains the UDF step definition. A geometrical set contains the planes. The UDF is located here. This is a resource table, and this is the knowledge pattern. The following part of this video shows how to create this data step by step with few comments when necessary. Using a PLM type stair is useful if you want this part to publish parameters in IFC format, for example. This curve will be used as the input of the UDF for the staircase definition. This parameter is moved inside the geometrical set to clearly identify that it will be part of the UDF. These two planes will be inputs of the UDF, and to clearly show it, it's a good practice to isolate them. The following steps shows the details of the UDF design logic. The creation of this vertical line is to avoid selection of XY plane as an input of the UDF. You will find a dedicated tutorial on this topic in this YouTube channel. Relocate the formulas under the geometrical set of the UDF definition so it really contains all items of the stairs step definition. Rename the final feature and put unnecessary elements in no-show. Now create the UDF. Select elements from the result up to the entries, including the parameters but not the geometrical inputs. Rename the UDF. Cautiously rename the inputs. It's handy to make a print screen of these names, as you will be needing them when writing the script. Define the UDF parameter, and again capture its name to be reused in the script. Now let's declare this UDF as a resource. Add a resource table. Add an item called resource 1 in this resource table. Declare it as UDF and select it like this. Then create the geometrical set to receive the planes needed to construct every steps of the stairs. Then create the knowledge pattern. Create the list of planes and the list of steps. If you are using knowledge pattern for the first time, this is a short example to show how it works. Declare your variables using keyword let. Use the language browser to search for function by the type of object they use, or return. Or search for function by their names. Click to get documentation with example. Double-click to add function in your script. Note that you can fill the function argument by a selection in the tree. And click on this icon to debug your script. Now let's go back to our model. This part of the script will measure the Z expansion of the 3D curve. The result is only the notification on the top right corner. The second part of the script will create the list of planes. This sequence shows how to fill function create or modify datum interactively. This last part of the script will instantiate the UDF steps. Note that if you change the stairs width, you will need to run again the knowledge pattern to update the stairs. This is because there is no link on the UDF parameters. But you can create these links if you follow the dedicated tutorial on this YouTube channel. If you change the geometrical input, the UDF will update. but you will need to run the knowledge pattern anyway to create the missing steps of the stairs. For this purpose, the knowledge pattern can be triggered with the global update. Now let's review the frequent mistakes in knowledge scripting. To forget to initialize the counter of loop, and this is very difficult to detect afterwards. To forget or misspell the inputs or the parameters of the UDF. This is why it's handy to capture them in a print screen. And finally, to forget the end-modified template statement.